those who are taking data mining and warehousing, can you type number 1? Not yet. Okay, that's okay. Um, okay, so this lecture is related to data mining. It is called text classification. So text classification mainly dealing with how do we classify the text. So provided that you have a few documents, how do you classify them into type A or type B, predefined classes before you perform the text classification? Okay. So this problem occurred a long time ago, in which when the librarian tried to store document, and then they wanted to retrieve the document for use in the future. So what they do is that they need to label the document, and they assign a unique identifier to each document, but they are not allowed to find the document on a subject or topic, because they do not have the algorithm or the program to look for a subject or a topic related to the document. So what we wanted to do is we want to group the document by common topics or concept or domain, in which each domain will have a meaningful label, and this is what we call class. So we could name them ICT or medical or engineering. So this is what we call the common topic, or a domain of document. Okay. So what we want to learn in this session is that how do we classify the text, um, and how do we associate the document with the classes. So when we say text categorization, we refer to as categories. Classes are referred to as categories. So classes and categories are two different terms, but they are referring to the same concept. So we consider classification and categorization the same process that belong to supervised tasks. So supervised tasks meaning that they have been trained. Let me. Okay. So this is a very important term. Supervised task means before they can classify the document, the algorithm has been trained um, using label or using name of the class previously. Okay. We also have another problem that related to text, in which we can cluster them or group them into cluster. So this is what we call clustering. For this one, this is called unsupervised tasks. Unsupervised meaning that we do not refer to any label, but we cluster them, or we divide them into a few clusters based on the content of the document. Okay. So for text classification, this is one of the way on how we can organize the information. And what we wanted to do is, provided that we have thousands of documents, we want to make use of the information for business decision. So sometimes we wanted to look at certain technology, or we look at certain concept. So we retrieve all the document related to that concept or related to that area, and then we perform some analysis, and then we can perform no, then we can make some decision. So just now I have asked you, have you taken data mining or machine learning? So this is related to machine learning. Next semester for data science, we will be offering the machine learning for knowledge discovery. So you will learn more algorithm on how do you learn data. They are divided into supervised tasks, unsupervised data, no unsupervised tasks, and also semi-supervised. Okay. So when we say machine learning is an algorithm that learn patterns in the data. Okay. So what we do, we will train the machine learning algorithm. We say if you see this pattern, this is class A. If you see this pattern, this is class B. So basically, we are training the machine learning algorithm. So like I mentioned just now, we have a few type of machine learning algorithm. So in this session, we will look into these two. Okay. So supervised learning meaning that we have some label that we can refer to. Okay. For supervised learning, we do not have any reference. So what do? We just cluster them or we just divide them based on the content of each of the document. Okay. So like I mentioned just now, supervised learning, they need training data. So we say if you see this pattern, they belong to class A. If you see this pattern, they belong to class B. So we provide them input or training data. Um, However, in unsupervised learning, we do not provide any training data. Okay? So these are some of the example of the algorithm. So we will look into this one. Okay? If you planning to take machine learning, so you will learn more about neural network and many more. Okay, for the semi-supervised learning, we will mix some of the data from here and also from here. So some of the data has labels, some of them do not have any label, so that's why they call it semi-supervised learning. Right? So this is the definition of text classification. Given the document that we have, and also we have a predefined label. So this is class 1, or class 2, up to class L. So it depends on the domain of the problem. Some of them have two classes, some of them have more than two. Okay? And also we have a binary function that map the document to the class. Okay, so this is the document, this is the class. So what we will do is for each pair of the document and the class, where the document belong to uh, collection of document and also the class member belong to set of class. So we will assign them to one if this document belong to this class, otherwise zero. Okay. So the whole idea is we want to classify each document into their own class. Okay. We also have a few situation in which for supervised algorithm we have multi-level and also we have single level. This one differentiate the definition for multi-level. For multi-level, one or more labels are assigned to each document. That means for one document, they could be belong to more than one class. So for example, like this is binary classification, meaning that we only have two classes. We also have multi-classification in which we have more than more than two classes. Okay, and this is what we call multi-label, in which this picture belong to two classes, which is the cat and the bird. Okay, so that's the differences between binary classification, which only has two classes, multi-class classification, they have more than two, and multi-level classification, in which each document could be belong to more than one class. Okay, and for the classification function, we define them as binary function of document. So remember that this one is the document, this is the class. So we could also modify them to compute the degree of membership. So there is another concept in which we can assign the class based on the degree of membership. So for example, like this, um, the cutoff is here, in which if the membership degree is less than one, so they belong to not tall. So this is for the height lah. So if the degree of membership is higher than one and one, so they belong to the tall category. So the classification function here could be more than one. So this is square. So this is more like there is a slope here. Okay. So for this one, if the degree of membership is 0.7 and below, so they belong to not tall category. If the degree of membership is greater than zero point 0.9, so they belong to tall. So this is another area that they have been research. How do we perform the classification based on degree of membership? Yeah. So for this one, for this lecture, we will look into unsupervised algorithm first. So in which we look into clustering and naive text classification, naive text classification. And for clustering, we have two type of clustering. One is partitional, and the other one is agglomerative. Okay, and for the partitional clustering, we have two types: k-means and bisecting k-means. Okay, so we will look into these two. And also for the agglomerative clustering, we have three types: single link, complete link, average link. So these are the technique available. Of course, there are more, but just to give you an idea that for agglomerative clustering, we have a few variant of them. For the naive text classification, we use the direct matching. So we will look into this one later on. Okay. So we use the vector model. So the vector model here, you have learned vector model in which you construct the TF-IDF matrix. So this is referring to the TF-IDF matrix, okay? Vector. So each document can be represented as a vector of weightage that you have performed in lecture 3 and 4. And for the supervised text classification, we have a few techniques. So if you're planning to take the machine learning, and of course the data science student, you will have to take the machine learning. So you will study most of this algorithm. Okay, decision tree, nearest neighbor, relevant feedback. So you have studied this one, okay, in the previous lecture. Naive Bayes, support vector machine, and ensemble. So you will study this one in lecture 10. Okay. So let's take a look at the first type of learning, we call it unsupervised. So unsupervised means we do not refer to any label. Okay? We just cluster them or divide them into groups depending on the document, no, depending on the content of the document. So we have all this. So we look into the clustering first. Okay. So the input for this clustering algorithm will be a set of documents to be classified, but there is no label. Okay. So the task is we want to separate the document into subset or cluster, and this is what we call clustering. Example like this, if we have a set of collection, what we wanted to do is we want to divide them into 5 clusters depending on the content of the document. So the K here refer to 5 cluster. Okay. So afterwards, we look at the content of this document and we find one term or one concept that can be used to represent that cluster. Okay, so we change them to name. Okay, so 5 classes. Initially, we have 5 cluster. Then we find a keyword that can be used to represent each cluster, and then we call them 5 classes. Okay. So how do we actually divide them? For example, like this, from your input selection, and then from K and K, we wanted to divide them into 5 clusters. So we will assign them into 5 groups. Okay. So how actually we perform this? The issue that we face when we perform clustering is that what is the best value for K? 3 cluster or 5 cluster or 10 cluster or 100 cluster. So the quality is much lower. So one have to perform a few clustering process before they can finally say K equal to this value will be the best one. Okay. So if we have the class label provided, the clustering is more effective. But since this is called unsupervised learning or unsupervised task, we do not have the class label. So we have to run through the clustering process, K equal to 5 or K equal to 7. And one of the practices that they use is that they look at the number of document and then they take the square root of that number of document. So if you have 100 document, they say the K value will be 10 because the square root of 100 will be 10. Okay? So we will look into this K-means clustering. We will have 2. One is K-means, one is the bisecting K-means. Okay, for the K-means clustering, the input will be K. The user have to define what is K. Okay, so for each cluster represented by each document centroid, which means that for each cluster that we have, we will pick randomly in the list of document to be the center of the cluster. So, for example, let's suppose we have K equal to 3. So we assume that there will be 3 clusters. Okay. So at the center of this cluster will be one document that we have picked. So the remaining document will be assigned to the nearest neighbor. Okay. So this is the algorithm. So we wanted to partition the document among the K cluster. So each document will be assigned to the cluster which closest centroid. So meaning that let's suppose we have this document lah. So this is in the 2D dimension. Okay? Let's suppose this is the position of the document. So let's suppose we pick, let's suppose we have k equal to 2. So we will pick randomly from here the two center. So we pick this one and we pick this one. Okay? So that means this is the centroid of the cluster. So for the remaining of this document, I will assign them to the closest centroid to be one cluster. So what I can see from here is that maybe this one belong to one cluster and then this one belong to one cluster. So it means that for each of these document, we will be assigned to the nearest centroid. Okay. So we will use this formula. So this is Euclidean distance in which we can measure the distance between the center here to the other document. So basically we are using the same formula that we use in the lecture 3 when we want to find the ranking. Okay. Okay, this is an illustration. We start with this initial setting. So in this one, k equal to 3. K equal to 3 means we have 3 clusters. So we pick randomly, and then for the remaining of the document, we assign to the nearest center. So you look at the color. So if red, they belong to this cluster. If blue, they belong to this center, and green belong to this. Okay. So once we finish with the first iteration, what we wanted to do is that we want to find a new centroid. So it could be somewhere here, because if you look at the cluster here, okay, so the new centroid will be here. Similar to this, the new centroid may be here and so on. Okay, so let me erase this one first, because I believe we have this illustration. Okay. So as you can see, I press the keyboard key. The center will move to the appropriate center. Okay. So what just happened is that in the first iteration, we pick 3 center. And then we assign the remaining document to the nearest centroid. Once we have done that one, for all the document, so we recompute the center. How do we recompute the center? We basically add up all the value of the vector here, and then we take the average. Okay? So that center will be the new center. And then again, we reassign again all the remaining document to the nearest center. So for example, like this, after the second iteration, your cluster is like this. So the new center could be here. Okay. So we will keep go to the next iteration until there are no changes of membership for the cluster. Okay. So these are the processes involved. We have 6 iterations because on the 6th iteration, there the centroid and also the membership of the cluster does not change. And that is the optimal result. Okay. So basically how it happened in the real document. So let's suppose we have this 6 document. Okay. So remember that this is the keyword that that we have in our document. So this is keyword 1, 2, 3, and 4. And this is your TF-IDF. But in this example, we make it a simple number. Okay. So this is basically term document matrix. Okay. Okay, what we wanted to do is we want to do two means cluster. So which means that we will pick randomly two document here to become the center of your cluster. Okay, so we pick this. Actually, we have more than 6. Okay, so let's suppose we pick this center K1 and center K2 randomly. Yeah? So it happened to be document 3 and document 6. Okay, so what happened next is that we assuming that we have two centroid here. So for the remaining of the document, we will assign them to the nearest centroid. Okay, how do we perform that? Then we use the formula that's given. So first we do it for document 1. So for document 1 to document 3, okay, so this is the distance between document and, so what we do is we take this number minus this and we take the square, and then we do it for 4 and 2 again, okay, and then 5, 5, 1, 3. We take the square, we add up all this together and take the square root, we get this number. So this is the distance between document 1 and document 3. Okay, now we want to do for document 1 and document 6. We do it because document 3 and document 6 are the center of the cluster. So we only compare these two. Okay, so we perform again. What is the distance between document 1 and 6? So we take the differences, we square those number and add up the number, and we take the square root, and then we get this. Okay, so based on the number, the smaller the number, the closer they are. So which means that document 1 is closer to document 3. So that means I will assign document 1 to document 3 cluster. Okay, so this is the cluster. Okay, so this is the cluster. Okay, so on the next slide, I will compare again document 2 to document 3 and 6, and we pick the smaller one, and we are saying that document 2 also belong to cluster 1, and we repeat for all the remaining until we done with document 7. So once we have done with document 7, so we have two cluster here. So in cluster 1 we have 5 member, and cluster 2 we have 2 member. Okay. So what we want to do next is that we want to find the new center. So what do? We add up all this number that belong to cluster 1, okay, and we divide by 5 because we have 5 membership here. This is actually taking the average. So this one is divided by 2. So again, with the new center for K1 and K2, so we will do again for the all document, and we assign them to. Okay, so this is your new center. Okay, so this is your assignment number 7 lah. Okay. Okay, for that's for the k-means. So based on this example, we know that given a series of document, we can randomly pick 2 or 3 of them to become the center. Then we assign the remaining document to the cluster that having the closest to the centroid of the document. Okay. Compared to bisecting k-means clustering, bisecting means we divide the group of document into two, bisect them. Okay, so this is just the illustration lah. So basically k is equal to 2. So in the initial step, we assign all document to a single cluster. So we split them into two. Okay, so each time we split them into two, for example, like this. But the threshold will be depends on number of document in each cluster. Okay, so for example, like this, we k equal to 2 means we divide them into two, and the stopping criteria is we have 4 document in each cluster. So basically, if we have 15 document here, and then we divide them into two. Okay, so we keep splitting them into two until the number of document is 4 or less. Okay, so this one we still have to divide into two. Okay, so this is just an illustration. How do they divide into two? It depends on the distance between the document. So we can use the same formula. Okay. So another type of clustering is called agglomerative or hierarchical clustering. So for this one, what happen is that we combine the document based on the similarity. Okay, no, we combine the document into the same cluster based on the similarity of the document. Okay. So for example, like this, this is decomposing. No, this is from top to down. We have two types. So this is we divide them into two and so on, so on. Or we start from small and combine them to become a bigger cluster. Okay. So we will look into this. Okay. How do we perform the agglomerative method? So basically what we want to have is that we want to have a set of n document, and also we have the distance matrix. So you have performed this task in which you can construct a matrix that measure the distance between two documents. Okay? And then what we want to do is that we want to assign each document to its own cluster, meaning that we will group them. We will find the two closest document and we will merge them together into one cluster. Okay. Let me show how it works here. And for this one, we have a few variant also. So it depends on the distance between the cluster. So this is, we have 3: single link, complete link, and average link. And basically this is the formula. So basically for the single link, we are looking at the minimum distance between two members that belong to two different clusters. Okay? And this one referring to the maximum distance between two members that belong to different clusters. And this is basically finding the average link between all the documents that we have. Okay? For this one, we start with cluster of individual point and distance matrix. So this one, we assume that kita ada 12 di sini, and we have so each of the document here is considered as one cluster. So we start with 12 cluster di sini. Okay. And also we have the distance matrix. So the distance matrix show how close two document or two cluster together. Okay, so for example, let's suppose we find the smallest value in this distance matrix is this one. So that means we will need to combine P3 and P5. So P3 and P5 will be here. So they will be combined. So it depends on the proximity matrix or the distance matrix. Okay. Let's suppose we have this. This is after a few iterations. So this one meaning that P1 and P2 are combined together to become one cluster and so on. This P10 and P11 are combined and then later on combined with P12. Okay, so they are combined based on the distance. Okay, so let's suppose we have 5 cluster here. Okay, and we found that C2 and C5 is the closest one. Okay, so this is the smallest value. We assume that the smallest value is found here. Okay, so meaning that we need to combine this. Okay, so what happened is that we combine that one, we combine 2 and 5. Okay, here. Um, Initially we have, yeah. So this is, we combine two of them. So what happened is that now we have 4 cluster. So now we have 4 cluster. So we want to remove this and also this, and we will have this one. Okay, because we need to find a new distance between cluster 1 and the combined cluster here. So what is the value here? Similar to all this one. Okay, so that is the tedious task that we need to perform every time we merge the two cluster. We need to find the distance, the new distance. Okay, so like I mentioned just now, we have 3 types of variant for the agglomerative clustering. So the difference between the similarity between two cluster can be defined by looking at um, the distance between the two document in two different cluster. So for example, like for the single link, we look at the minimum distance between two documents from different cluster. And for the maximum, we are looking at the maximum distance between two document in two different cluster. Okay, so this is cluster 1, this is cluster 2, and each of the dot here is assumed to be document. So in K1 we have 4 document, in K2 we have 4 document, this dot. Okay. Okay, so the average length will be the average distance for all the member that we have in these two cluster. And the distance between the centroid will be this. So how do we find the centroid here? So basically we are taking the average of all this value. So we add up all this value and divide by 4. Then we get the centroid here. Okay. Okay, how does it work in a real document clustering? So given that we have this document 1, 2, 3, and 4, so we need to perform the distance matrix. We need to construct them. So this is what we have. Okay. So this is the distance between document 1 and document 2. Okay, so we should pick the smallest one. So this one. So which means that we need to combine document 2 and document 3. Okay, in the next one. So since we have combined document 2 and document 3, the new center or the new, of course, they will have a new center here. And we need to perform the distance calculation again. Okay, so the new center for this will be, this is 1.5, this is 1.5, and so on. Okay. So based on this, we need to perform the distance calculation. Okay. So from here, the smallest value is this. Then we combine document 2, 3, and 1. Okay. So once we have combined all these three, again, we need to find the new center. So the new center will be this, and the distance metric is that. And then lastly, we have that. So basically, if we have 4 documents, so this is document 1, document 2, document 3, document 4. So first we combine with what? The first one, 2 and 3 first. So we combine these two first, and then we combine these two, and then lastly we combine this. So this is how it looks like when we draw the Venn diagram. Okay, so we combine 2 and 3 first, and then this cluster with document 1, and then finally we combine the last one. Okay, this one is based on centroid. Or this one, we are looking at between the centroid, the center. The center is this one. Okay, so we could also perform the clustering using single link. So how it looks like. This one is based on single link. Okay, single link method. Okay. So we do the same thing. We construct the no, for this one again. So we construct the distance matrix because at the initial stage we assume one document as one cluster. Okay, so we still use the for each document they become the individual member in that cluster. So we take that one and we combine. Okay. So now, since we combine document 2 and 3, that means we basically have document 1 here, one cluster, and we have document 2 and document 3 as one cluster, and document 4 as one cluster. Okay, since we are using single link, so when we determine, try to determine the distance between these two, we have to find the smallest distance between D1 or D1, D3, D1, D2 or D1, D3. So that will be the distance between these two clusters. We find the minimum distance. Okay, so similar to this, if you want to find the distance between these two clusters, so we have to compare which distance we take, distance between D2, D4 or D3, D4, because we have two measurement already. Okay, so that's why in here we are comparing the distance between this document 1. This is 2, this is 3. So this is in one cluster. So we wanted to measure the distance between this and this. And we found that smaller value will be 3.32. So in that case, we will not take this one. So we will take this one as the distance between these two clusters. Okay. And similar to D4, when we have D4 here, so I need to compare between this. So we find that lah. Okay. So the distance between, okay, let's write this one. This is 3.32. This one we are taking, which one? We're taking this one, which is 3 and 4. So 3 and 4. So this is 8.72. Okay. So we will ignore this and we ignore that. Okay. So from here, based on the value of the distance, so we combine this because of this is smaller than this. So there is a two level of comparison. One is between the member of the cluster, and the other one is between the distance between all the cluster that we have. Okay. And we combine this one. Okay. So the next step is still the same. So we this is the distance matrix that we perform after we compute all this. Okay. So then we merge them and so on. So this one we are finding the minimum between all these documents. So cluster 2 and 3 is merged with document 1. Okay. So I've given you the second exercise. No, this is assignment number 8. Okay. So you will need to perform the hierarchical clustering using single and complete. So this is minimum, this is maximum. So only by doing the exercise, then you can start thinking how actually the agglomerative clustering can be performed. Okay. So for the last part of this lecture is a very brief one. So naive text classification perform the classification based on direct matching. So what we have is that we don't have any training example, but we have a set of document and also a set of label here. So what we want to do is we want to associate one or more classes with each document in the document set. So we will match the document term with the class label. Okay. So for example, like this, we will look at the similarity between, remember that when you are learning lecture 3 or lecture 4, query and the document, we find the distance between these two. Right? So similar to this, so based on the document that we have, we will measure the distance between that document with the label that we have. So this is two different vectors. So if you look at this formula, looks familiar, in which we are looking at the vector distance using similarity function. This is cosine function. Okay. Okay. So this is the example that we have. For example, like we have document 1, 2, 3, and 4 here, and we have classes here A, B, C, and the label is this. So what we want to do is for each of the document that we have for document one, we want to try whether they belong to A or B or C. So how do we perform that? So we just measure the distance between this document with the label that we have. So this, if you recall back, this could be your query lah. Okay. So remember that you perform the ranking between the query and the document. So similar to this, we can um, perform the same task here. So we will assign the classes here, one of them, to the nearest distance. So if document one is more similar to do, then we will assign class A to this document. So this just give you an idea lah. We can perform also the naive text classification by looking at the label and also the content of the document. That's it. So we will study more on the text classification part 2 next week lah. Okay. So any question? You okay? If you're still there, can you type number 8? Okay, so if you miss some of the point that I'm trying to emphasize, I will share the video again in the YouTube, and you can watch over many times. Okay, so any question?